recent one is because like you came in pretty and kind of screwed up a tool assignment and like hand in. So it's really like she's like to leave it and like redo it. It's like the third lab where it takes literally 20 minutes to do
Let's talk. Let's do it. So here are all the details that you need to know for the midterm. So make sure that you come to the midterm. Please come to the midterm. Unless you have a really good excuse. So if you have a computer, then you're going to CIRS. And CIRS has some power. I've never been inside of that room, so I can't promise you anything. But I think there's some power plugs next to seats. So bring your computer, charge up the battery before you go, so that you have enough power for the hour and a half if possible. If you don't have a computer, come to the lab. So there's a bunch of lab locations. Just come to 008 initially, and then we'll figure out where to place you so that you're nicely load balanced across all the rooms. So the exam is an hour and a half. It starts at 6:30, goes to 8. We're probably going to be there at 6. So if you want to come early, get a good spot, get all your pencils out, all this good stuff. Come at 6, and you can come early to get ready. This exam is going to be mixed, so we're trying to keep the two sections in sync as much as possible. So you'll be taking the exam with the largest section in CIRS as well as in the labs. So expect to see people. So what are we covering? We're covering everything, kind of like the QA talked about on Monday. And then the Piazza is down, so, well, down as in you can't create new posts, but you can still read stuff, existing stuff. And so there's a couple of posts that you should look at. The first one is the midterm rules. There's been some interesting follow-up questions about this. So you definitely look through this and kind of understand what you're allowed to access and not allowed to access ahead of time. So you're allowed to access the repository code that we give you, and then the Java documentation. If you have your own laptop, you can download the Java documentation ahead of time. Just preload it and figure out how to use it. Yeah.
On that post, or somebody's asking, you supplied the website link. If we go to the website directly from that link on our laptops, is that allowed, or do we have to download it?
No, you can go to this link on your laptop. That's fine. Yeah. So you'll have Wi-Fi with hundreds of other people, and hopefully Wi-Fi will work for you. But if you don't want to depend on that, then you can go ahead and download it as well. So it's totally fine to access the internet for the documentation. So that's one post that's important to take a look at. Just read through it, make sure you understand it. It's good to also go to the docs and just browse around. Make sure you're familiar with them, right? If you've never used the Java docs before, it can be a little bit overwhelming, to find the thing that you're looking for. So make sure you can navigate it. The second post is the clean workspaces post. So during the exam, we expect you to only access code that we make available to you for the exam. So we don't want you to look at prior code that you've written or prior code that we made available to you. Partly because you might have some hints, partly because it might confuse you, right? Because we might reuse some of the code. So you need to clean your workspace in Eclipse. And so there are kind of two ways of doing this. So here's my Eclipse workspace. One way of doing that is to select all the projects that you have here and then deleting them. Right? That's like nuking your workspace. So that's not a good idea if you have a bunch of code that you want to save and you want to delete. So this is kind of an extreme solution to this. Another solution is to create a new workspace. So in Eclipse, you can have multiple workspaces and kind of switch between them. And a workspace just remembers a set of projects that you're working on. So if you create a new one, you'll just start with no projects, and then you'll add SVN, and then you'll be able to check out the things that you need for the midterm. So I can give you a little demo of how to do that here, just real quick, because I'm assuming that a lot of you are going to want to do this. So if you have your Eclipse open, if you go to File, Switch Workspace, this is kind of the key thing. So here, if you don't have any other workspaces, or if you want to create a new one, you just go to Other, and then Eclipse will prompt you and ask for where do you want the workspace to exist, the new one. So I can just specify, my exam workspace. And so I'll create this directory, and this is where it basically needs to restart. So Eclipse restarts and starts into the new workspace. And when it loads up, I'll have no projects. And it starts off in this really blank screen, like it was run for the first time. So no projects. So once you get here, you still have to do the one extra step of adding the SVN repository. So when you create a new workspace, all of the settings get nuked. So you have to import the SVN repo information. So for this, you go to Show View, Other, find the SVN repositories view, add that in, and then down below I can right-click and just add a new repository location. And this guy I can get from the website. We'll also post it online. So basically, it's this thing from Lab 0. So adding the lectures URL. You might get an error. Just click OK through it. Hopefully it should just work. And voila. So you have all the lecture repositories. Yeah?
If we were to go to computer labs, will all of this be set up?
That's a good question. I'm not sure if it's going to be set up in the computers on the lab. I think there, if you log in, if you've never used Eclipse before, then you'll get the fresh screen. But if you've used it before and it has some state, then it'll have some projects, so you'll have to do this. So I think it depends on the student. And so here, for the midterm, the code that we'll have you use during the midterm will be in the lectures repository. Okay, so you're basically going to check it out just like you would normally. You would right-click on one of these folders, say checkout, it creates a new project, downloads a bunch of stuff, and so you'll get your source code there. Okay, any questions about this process of creating a new workspace? So if you have a computer, you can do this ahead of time. I encourage you to do it ahead of time. You don't want to be doing this during exam time. Okay? Yeah?
If you're using lab, can you do it slightly before the midterm starts?
Yeah, I think if you cache I just don't know how it's set up. So if the lab computer is associated with your username, then you can definitely go there ahead of time and do it. And then when you log in, it's just going to have that. Okay, great. So that's kind of important. So to take the exam, you need a clean workspace in Eclipse. So exam details, what else? Bring your ID cards, right? We're going to be checking ID. Bring water, maybe. What else do you need? Pens, right? All the typical stuff. Kind of think through all the stuff you need to bring. I always forget stuff, so good to do. All right, so what are we doing today? I'll switch over to my other workspace. And we're going to go through the programming assignments. We're going to go through 3 of them. So the first one, the Spaceship one, it's kind of a really obvious one at this point, I hope. So we'll just go through the email state machine, the where am I, and the text parser. So we'll go through solutions for those. And then at the end, we'll have maybe 15 minutes left, I hope. And I have another kind of programming practice thing that you guys can do on your own. And we'll kind of run it like a lecture lab. We'll work on it, and then I'll try to solve it at the end. So let's jump into the programming assignment. So let's start with where am I? I think that was the earlier one. Okay, so in where am I, the basic assignment was you're given this partial implementation where you have a where am I class and you have a which continent method, and the continent method takes a locator. Now, now that you know about interfaces, this locator object is actually an interface. Right? I can jump to it, and I'll reveal that iLocation service is an interface that defines a bunch of methods that get me latency to different continents. And so the point of the assignment was fill in the body of this method to actually determine which continent you're on based on the latency. Right, so this is a great example actually of interfaces where we gave you the interface, but we didn't tell you about the implementation. We hid the implementation from you. And then you had to figure out how to use the interface without knowing the implementation. So a good use case for interfaces. Okay, so what does the solution look like for this guy? So on the server side, we actually implemented a bunch of these interfaces, right? So we implemented mini versions of locator services. So here's the Atlanta one. And they're really simple. They just return the value, right? They're just hard-coded. No magic there. And then the which continent method works as follows. So basically, I mean, people had numerous solutions to this, and some people had really kind of complex nested code. This is more linear. And the idea here was you're going to remember some state. So you're going to remember your smallest location, smallest latency, and then you're going to remember the location that it's associated with. So here's, T old, you initialize it with time to Africa, and the continent is Africa. And then you're going to update it based on whether or not the new latency that you observe is going to be smaller. So you'll do this for each of the continents. So this is Antarctica, then you do Asia, then you do Australia, and so forth. And then at the very end, once you're down here, you know the continent contains the right continent string, and you just return that. Okay, so pretty straightforward. Any questions with that? This assignment? Okay, let's move on to the second.
What if you're equidistant between two continents?
If you're equidistant, then you have a problem. You don't know what to return. So we made sure that it was unambiguous, that you would never be equidistant between two continents. All right, let's do the more interesting one. So the email state machine. So email state machine, we kind of use from a little bit of graphic. So here's the picture of the state machine. So the assignment was, we give you an implementation of the state machine, this diagram, and then you're supposed to test it. Right? So you're supposed to write tests that explore all the different paths in the state machine. And then one interesting twist on this is that we also implemented by making a couple of bugs. So the implementation we gave you was buggy in a couple of places. So you were supposed to find the bugs and then make all the tests pass. Right? So what we gave you was a little bit more code than last time. So we gave you this, again, an interface to a state machine. So an email state machine can do all of these things based on kind of email actions. And then, of course, it extends another interface, the iState machine, which is even more abstract. So kind of on a very general level, what you could do with the state machine is you could query whether you're in an initial state, in a terminal state, you could find out the current state, and then you could just initialize the state machine. So very simple. And then the email state machine includes all of those methods, and then a few more. So the implementation here, which actually implements this interface, implements each of those methods. Right, so it maintains some internal state, it knows about what its current state is, and then it basically transitions between states based on the input. So your task was to fill in this class, which is the tests. So here we gave you a small illustration of what you would need to do. So you basically write these JUnit tests, annotate them with test, and for every test you would initialize the code and then have a series of calls that look like this, where I check if I'm in initial state, maybe I check if my current state name is logged out, and then check that if I log in with the right credentials, then I end up in the login state. So there's going to be a bunch of assert statements. Assert true, assert false, assert equals, and those are going to be verifying that my implementation does what I want it to do. So, solution to this is going to be a bunch of code in this class. And the solution looks like a bunch of test cases. It's long. I mean, it's, what is it, about 20 lines long. So you start off with this example, and then, you know, it just keeps going. You initialize in your test, and then you try out different methods. So you try to log in, compose email, cancel, compose, email again, and so forth. So there's a couple of simple cases, or a couple of tricky cases, like the fact that if you attempt to log out in the logged out state, then you should get back an empty string, right? Which means that you can't perform that action in that state. So there's a bunch of those. And then there's logging coverage, which was a little bit tricky because when you log in, you could log in with the right username, wrong password, you know, wrong password, right username, wrong password, wrong username, right password, right username. So there's kind of 4 cases. And you have to try each of those in order to have coverage. And then there were the actual bugs. So the bugs they're pretty simple, but the mind twist was that you had to make the test pass. So by passing the test, you're basically showing that there exists a bug. And that was kind of the challenge. Any questions about this assignment, the solution? Okay, let's do the last one, the text parser. So you had to do that one last week. So text parser, we gave you a number parser and a sentence parser. So the idea was we give a string to one of these classes, and then they parse out various things, various items. So you could parse out sentences, you could parse out strings, you may want to parse out more things. So the number parser just parses out integers, and it's a little hairy. There's some code in here that does stuff. But then it can reason about the things that parsed out. So you can ask about what is the maximum number that you parsed out, or the min, or take the sum of all. So these are very specific to the number parser. And then there's the sentence parser, which is a little bit more interesting in that it could parse out sentences of different varieties, right? So sentences that end in a period, sentences that end in a question mark. And then your task was to extend this code and to add a new kind of sentence that you could parse. So you could parse sentences that end in exclamation marks, and then change the number parser, create a new parser, the truncating number parser, that would basically omit the last item that is parsed by the number parser. Okay? So a lot more code in this project. You can see a trend here. Increasingly giving you more and more code that you have to look through. So the solution, well, we have the truncating number parser. So let's look at that one. Actually, yes. So the truncating parser is relatively simple, but you really have to understand inheritance to write this code. Right? So the easiest way of creating this parser is to extend the original number parser. If you extend the original number parser, then you can reuse a lot of the same functionality that's already existing. Right? So you don't have to create your own parse method. You don't have to re-implement a lot of these methods. So the easiest way was to extend the number parser and then override the parse method. Right? So here I'm overriding the parse method. I could add the annotation override. I don't need to. But this, I'm defining another implementation for parse. And the one interesting twist in this implementation is that I'm going to reuse my supers implementation. So I have the first call in this method is to do super.parse, which calls the parse method in number parser. So the first step is, parse out all the numbers. And for that, I'm reusing my number parser implementation. And after I parse them out, then I get to decide, do I remove the last item or not? And whether I remove the last item, well, that depends on whether my list is empty or not. Did I parse anything? If I didn't parse anything, I don't do anything, right? I can't actually truncate an empty list. But if I parse something, then I just remove the last item. Yeah?
I have a question. In the super method, in the last line there was a return true, right?
In the number parser?
In the super, I mean in the parser of the super class.
Yeah.
Why would you return true again if it's already there in the super?
Because here, the return true is going to come out here, right? And so return true just returns from that invocation. So I also need to have a return statement for this invocation. So if I comment this out, then Eclipse is not going to be happy because it says I have to return something, right? So I have to return something from this method. So that return returns to this location. So I could remember, so I could have like Boolean super's return value, and I can remember that value, right? But then I still have to return something from this method. And you know, like a really more robust implementation would actually check the return value of my super parse. Yeah.
I was a little confused because when you wrote super.parse, we're actually using parse, but the parse will return a value, return true, and that won't affect the. I was just thinking maybe that true will be mistaken for a true, and it will just end the method.
No, so that value returns just like, you know, when I'm calling. That's another good example. Maybe a number. You know, when I'm calling this thing, like toParse.length, that's like the length of my string, right? The return value of that comes back and is replaced, is put into here, right? So that return value does not at all influence the return value of this method. It's used inside of this method. So when I'm here, it's the same thing. When I'm calling super.parse, the return true just comes out on this line and is not, you know, I don't store it, I don't use it, so nothing happens to it. So then I have to, within this method, have my own return, another return. Other questions about the solution? So it's pretty short, but it has a lot of stuff in it. Yeah.
I just remember for the email state machine, you said there was 3 codes, like the 3 bugs.
$3.
Yeah, like the 2 were the terminal and the initial statement. There's a third history.
Yeah. So you're asking which one it was? Yeah, it's a good question. Let me go find out. I don't remember. So yeah, so the question is, there were 3 bugs in the state machine. So what were they? So here are the buggy cases. There's 3. So the first one is the initial state. If you're in the logged in state, it should not be the initial, but it is. Right? That's what this guy's testing. The second one is if I log in and I open an email, I'm in a terminal state, but I should not be in terminal state. And then the final one is I log in, I then open email, and I open email again, you know, there's no way to open email from the reading email state, but this allows me to open email yet again. So there's kind of a loop on the reading email state. So from reading email, I can call open email. Okay? So that's the third one. Alright, back to this one. Any other questions about the inheritance stuff demonstrated by this example? Okay, and then the sentence parser. So you're supposed to do the 2 tasks, right? The first one is add the truncating number parser. And the second one was change the sentence parser to parse for sentences with exclamation marks. So this required you to dig through the code a little bit and understand what's happening inside of the parse method. So there's quite a bit of code, but the key thing to realize is that if you look for occurrences of question mark and period, right, this leads you to chunks of code that you would need to think about in order to add new functionality. So the way I parse out a question sentence is that I need some code chunk here that will find the next position of the question mark. The way I parse out a period sentence, a sentence that ends with a period, is one where I first have to find the position of a period. So I have these two code chunks. So adding another one for exclamation point, well, just add one, right? You model it exactly after the other ones. And then the only one other thing is that you have to change this line of code. So the previous line of code had just this bit of code, where it would basically say, what is the first thing that I saw in my string? Did I see a question mark, or did I see a period? And then you have to augment this and to say, what is the next thing that I saw? Was it a question mark, a period, or an exclamation point? So you need to add that to the statement for you to be able to parse out exclamation points. Right? So this was the only code you need to add. Like add this stuff and then change this one. So kind of very different kind of exercise, right? So you're not creating a new class, you're not thinking about inheritance, you're changing existing code, which requires you to do a little bit of thinking about what the code there is doing. Any questions about this one? Okay, perfect. So I think what we'll do next is work through programming practice. So there's a new project that's in the lectures repository that you should check out. And the project is called Spaceship Extended. So check this project out and then work on these problems. And if you have a question about this or the midterm, anything, just raise your hand. I'll come up. Yeah, so I think that everything should be part of that.
So basically, like everything.
Yeah. Then there's a big hit.
Okay.
This is how it's done.
Yeah, it's true.
That is
Okay.
otherwise,
Okay.
that's it. Yeah, send me an email about it. Okay. And then I'll try to. Yeah, I mean,
So I think this depends on the coordinate system. So, you know, yes, in Java, the coordinate system for Java either moves but, you know, this doesn't tell you about, this doesn't assume any coordinates. Okay, then yeah, I mean, like in general, you have to. Yeah, I mean, if you get anything like that, we'll tell you the coordinates.
So let's say, like, is it one of these Java like object? Yeah. So we could say insert bottom left. Or you say we could say XBL, whatever next one.
Yeah, I mean, a for loop has a conditional, right? It's a conditional between continuing or stopping. The has next is it's a function. It's something we haven't covered. But basically, the way to think about this is that it continues as long as has next returns true on control point, which is why it's there. So for the midterm, if you get this kind of function, you can just specify the line numbers, like 73, or put a rhombus around it, or you put the actual condition. Yeah, that's also so that because you don't know that type of thing. So if you have to do this on the midterm, we'll tell you. Thank you.
You guys excited?
I'm just trying to get
Yeah, that's
No, because we it does need to have like a you create a point based on those two and you can test them. Yeah, so I create the points here, but then I would that and then test those two. You don't have to create here you check the X, Y, and then the bounding box of those two points. Yeah, but it was 30. Okay. Alright, thanks.
I would take up like every single Yes. So they have zeros.
Just hop right and read it.
Well, that's what computer science is. Yeah. Zero, this is
No, it's not.
Let's go over the solution. So, Spaceship extended, full package. So first question, I want to create a point class, right? And it has a constructor, it has a way of getting the x and y coordinates of the point. So, new class, it's going to be called point. So inside, I have a constructor, public point, int x, int y. Here I have to remember the x and y coordinates of the point. So I need some field, like int x and int y, to remember the location of the point. And the way I'll update those fields is by saying this dot x equals x. So I remembered the x coordinate of my point. This dot y equals y. I remembered the y coordinate of my point. And now I'm on to B and C. So now I want to retrieve those two coordinates. So I need something that returns an int. And I'm going to call it getX. And very simple, it will return x. I can also return this dot x. That's equivalent. Doesn't matter which one. Both are correct. And then get y, very similar. Public int get y, return this dot y. Okay, so that's the answer to the first question. Second question? Yeah.
Back in that code, instead of just declaring x to be an integer, we initialized it in the class, like said int x is 3 or something to start with, and then with this dot x and x equivalent inside of the getX method still.
Yes. Yeah. Here you're initializing it. Without initializing it, it's initialized to some default value by Java. Okay, so it's just a question of what is the value before you write to x. So what is the value of this dot x before this line? Okay, so no big difference. And the second question, you have to add a new class rectangle. So a rectangle takes a constructor. So we're going to have a constructor that builds a rectangle. And we're going to build it out of 4 points, or 2 points with 4 coordinates. So it'll be int x1, int y1, int x2, int y2. So that's my constructor. I have to have that constructor. And now I want to store these coordinates in my rectangle class. And the hint is that you want to use the point class. That's why we created a point. So let's have 2 fields, each one be a point. So this one be lower bound, lower bottom. I'll have another point, top right. And then I'll just do lower bound, point equals new point. And I'll create a point out of these first 2 coordinates. Okay, so I turned the first 2 coordinates into a point. Now I'll do the same thing for the second set of coordinates. So I'll do top right equals new point, x2, y2. So this is my constructor for the rectangle. And then the final question, well, there's a couple more. So I need a contains. So public boolean contains int x, int y. So this method needs to check if x and y are within the rectangle, within the bounds. So it needs to return some value. So the easiest way to do this is to check if x is greater than lower bound dot get x, and y is lower bound, lower bottom. Y is greater than lower bottom dot get y. And then I have to do a similar check for the top right coordinate. So I have to check that x is less than top right dot get x. slightly verbose way of writing it. But that's the solution. Okay, so make sure to read questions carefully on the exam. We're going to give you a lot of details, so you have to follow the questions well. And don't be late for the exam. See you tonight.
Concept